Kubernetes Secret Data Encryption and KMS v2, which is the alpha feature introduced in version 1.25. So let's try to understand. So before that, we will try to understand what is encryption. So what is encryption? So let's say you have a plain text file, right? Some file, and you will use some cryptographic key and apply some encryption algorithm, some logic, and it will become a encrypted file. Nothing but converting this particular plain text into the ciphertext. What is the ciphertext? Ciphertext is not readable by the human. Nobody will be able to read or understand, hack or reverse engineer what is this particular file unless they have this key. So this is called encryption. And how to, once it is encrypted, how to decrypt? The same key, whatever the encryption key I have used here, that key will be used to decrypt and get back the same file which I encrypted. So this encrypted file you can share with anyone, you can email, you can do whatever, so that it's highly secure, and unless if you have a, you will be able to. Now, encryption point of view, these are the two types. One is a symmetric encryption, other one is a asymmetric encryption. So this example is symmetric. So for symmetric encryption, you will use the only one key to encrypt, the one same key for the decrypt. So if you lose or if somebody steal this particular encryption key, he will be able to decrypt whatever the file you have encrypted. And other one is asymmetric. Asymmetric encryption point of view, you will use two different keys. Means symmetric point of view, only one key for encryption and decryption. For asymmetric, you will use two different keys to encrypt and two different keys to decrypt. That's in short about the encryption. And if anybody want encryption, please get the basic detail by doing Google search or any other medium, reading the book or anything, right? Envelope encryption. So let's say there is a cloud which is AWS cloud. Let's take not only AWS or Azure, Alibaba cloud or Oracle cloud or any other cloud. It's offering a KMS, which is nothing but a key management service. So what exactly it is means, if you go back to my previous slide, in order to encrypt this particular file, I have used this particular cryptographic key that used to encrypt and decrypt. So in the same way, in order to encrypt my cloud resources, right, I will use this particular KMS. So how it is I am a GVR, I will go and create my own customer managed key. I am a customer GVR, I will go and create my key, and so that all my cloud resources will be encrypted with this particular key. Whatever the key I created, that key will be used for the encryption. But here, envelope encryption point of view, this KMS key will create a data encryption keys, which is nothing but a DEK. In short, it is a two, which is asymmetric encryption point of view. One is a plain text DEK, other one is a encrypted DEK. So these DEKs are created for each encryption. So I have two different files. Two times I am storing, means two different set of keys will be generated. So how? Let's say this person wanted to encrypt this particular file, store it into the AWS, which is maybe for more than a 4 KB. Most of the cloud providers use this particular envelope encryption. This plain text file, I will take plain text DEK and combine it, apply some encryption algorithm, and it will generate an encrypted file. Now, while storing this particular file, I will use this encrypted DEK along with the file. Means wherever I store, along with this particular file, I will store this encrypted DEK and store it in a S3. That's how when you just drag and drop the file in a S3, this is how internally it will happen. It may not looks outside, it may not appear outside, but that's what the encryption happen behind the scene. And once you do this, this plain text DEK will be deleted from the store. This will be stored. That's what they call as envelope encryption. So here envelope is nothing but this is the along with the encrypted file you are storing encrypted DEK along with it. Maybe you can ask, if somebody steal this particular file, then will they be able to decrypt? No, they need this particular plain text DEK which is generated by this guy KMS. So, and how the decryption works, we'll see. Let's say I stored this particular file which is along with this particular encrypted DEK store, and this person wanted to decrypt. How the decryption happens internally? First, I will go to KMS, and KMS I will generate a data encryption keys. I will take this particular plain text data encryption key and add it to this particular file, and it will apply a encryption algorithm, and ultimately it will generate a plain text file. This is how a KMS decryption will works whenever you decrypt from the S3 storage or any other cloud storage internally for envelope encryption, right? And also asymmetric encryption is also the similar, right? But envelope encryption will be used as a part of a asymmetric encryption. Now, since we are in a Kubernetes point of view, let's say there is a secret, right? In the CKA what we learned is a secret you can create, right? So, and you will use some kubeconfig file and apply against a kube API server. First authentication phase and authorization phase, and then after that admission controller, whatever, if it is there applicable, and finally the secret will store in the etcd database. So here you created a secret and ultimately stored here. So, but wherever it's stored, by default it's not encrypted at rest. So at rest means the ultimate location is called at rest. At rest, whatever the you created a secret, it's not encrypted, it will store as a plain text. That's what the. So how to prove that? So I have a 2-node Kubernetes cluster which is one master and one worker node, which I have created by using this particular K8s cluster, which is by using a Vagrant, and which uses Ubuntu 22.04 and running on the container D. So now I have to create one secret, right? kubectl create secret. So I will create a generic secret one from the CKS. What this is the what the command where we created. It's a simple key value, key equal to pwd, and actual password is admin123. And when I create, the secret is created, kubectl get secrets, and when you type, then it's available in a which is a default namespace. Now if I wanted to see the secret, yeah, it's a simple kubectl get secrets, right? And secret one and -o YAML, this is the what the my secret, right, which is store as basically base64 encoded. And then if I wanted to do this is the what the this one. But here we are talking about the secret data is not encrypted at rest. So in order to prove that, right, as we know, Kubernetes control plane point of view, etcd, this is the what the etcd database, right? And etcd, in the etcd it will store. So in order to see, go inside and check whether it's there or not. So here 3 different ways I can check. So first one is I will go inside the etcd pod and I can verify. So for that I have to go inside this particular the pod, right? So there is a command which I have already prepared, and as well as in the CKA or CKS, this particular command will be used. So kubectl namespace is a kube system namespace, execute in interactive way etcd master, which is this particular pod where we are storing the secret in the etcd. So in the etcd and -s, it's a shell, and the command, what command I'm executing, etcd-ctl API equal to 3 etcd-ctl certificate key of etcd. So how these particular certificates are stored, where exactly? So, and I'll just copy this particular path, and I have explained already. So I will go inside my master node, and just bear with me a second, and I will go as a root user and back to. So if I do the ls-la and this particular path, so these are the etcd specific certificates, right? And here https and etcd database is runs on a 2379, and here the secret one which is created in the default namespace. So when I hit here, so if you look at here, whatever the create created secret as admin123, which is as opaque. So basically this etcd pod, when I queried, go inside and I will be able to see the data which is not encrypted here, right? That's what the in this particular slide, by default the secrets are not encrypted at rest. So this is a one way. And another way is you go inside the master node, right, and just clear it. In the master node also you can run this particular command, which is etcdctl. So whatever the command you run here, right, this particular command you can just copy here the master node, and here just paste that particular command. And by the way, along with that, make sure this endpoint should be presented in the form of a quotes, and along with that pipe hexadump and -c. And when you enter, so along with the hexadump and it particular the detail will be there. So this is a second way where you can just dig inside this particular text, it will be there as a plain text. So this is a second way. And the third way is go to the etcd database physical path, which in the master node. So cd var lib and etcd is the etcd database specific folder, and here go and ls. Here there is a member folder, cd member, then ls and cd snap, right? And just wanted to show the its directory. I am going one by one. And ls here there is a file called a db. Say if I say vi db, right, and if I open this particular file and search for secret 1, or see pwd admin123. So here at rest in the file system level, this particular data is stored as a plain text, so there is no encryption happened. So that's what the I'm trying to prove, that this in the etcd it's not encrypted. Then what is the solution? We can encrypt the data at rest. Means whatever the secret you are storing at the end location, you can encrypt at rest. Solution is encryption configuration. So yes, by using encryption configuration we can make secrets as encrypted at rest. How? Encryption configuration is a YAML file, which I have a GitHub repository, which is KMS v2. There here it's a simple YAML file, right? So under the resources, what resources you wanted to encrypt? I wanted to encrypt the secrets and the providers. So in order to encrypt my secret, who are the providers? One is AES GCM is a one of the provider, AES CBC is a one of the provider, and secret box. These will use the different algorithm to use the secrets. In this particular algorithm point on to, you are using a two keys. Here 2 keys, here 1 key. So these are the different provider. You can use anything and you can achieve encryption. That we will see further. And finally identity. So identity is represents whether you wanted to encrypt or not. So how to implement this encryption configuration? It's a very simple. Just to prepare a simple YAML file and specify the resource as a secret and specify provider as a AES CBC, which I have a GitHub repository, which is in the YAML file. There is a configuration, encryption configuration, resources, secret I wanted to, and provider. I will use any one of the provider, and this is indicates the list. And identity, have to keep it as a blank at the bottom, right? And that we will see in the demo now. And the key you will define. So if you look at the YAML point of view, key 1, and this is the secret which I wanted to. So I can use anything, any of the my personal key, but this is, should be base64 encoded. So that we will see in the further in the demo now. So this configuration, how to enable at API server level. So if you look at the API server static part, we will be configuring. If you pass a CKS, so you will understand this. So in the API server configuration level, you have to add this encryption configuration provider config equal to this particular path, and you have to volume mount. Otherwise API server don't know where you copied this YAML file. As simple as that. Now here in the previous slide there are the provider we see, right? These provider we use AES CBC. right? So here AES CBC, apart from AES CBC there is a secret box AES GCM and KMS and identity, which represent without encryption, and secret box is the fastest, and the strongest is KMS, and KMS is recommended. KMS uses envelope encryption, but of course KMS is a new solution. So before going to the new solution, first we will try to see what is this one and what is the difference is this one, right? Next, KMS provider for encryption. So if you look at the previous slide, KMS uses envelope encryption, and which uses a data encryption keys by using this one, blah blah blah, and this is highly recommended, and this is the strongest. We don't care about the speed, we care about the which is a strong or not, right? So, and KMS. So KMS point of view, there are two versions, KMS v1 and KMS v2. KMS v2 is recently introduced in version 1.25 as a alpha 1. What is this alpha? Usually releases are 3: alpha, beta and general availability. So this is the alpha, right? And if you go to the Kubernetes documentation here, and version 1.25 in the combiner, if you look at, just search for KMS, introduced a KMS v2 API and as a v2 alpha 1, as simple as that, and which uses DEK blah blah blah, whatever I explained, right? It's a simple paragraph. Now go back to the slide. So with respect to KMS, how it works, let's say you have AWS cloud or any other cloud where you are using a KMS service, and you have your own master key, customer managed master key, and it will generate a data encryption keys, which is a DEKs we have seen. In the etcd, every encryption will be stored as a envelope encryption. So you take a Kubernetes cluster and you use a KMS, that whatever the secret you store as encryption, which I explained in the second slide, right? So in that way it will store in the etcd, and this DEKs will be generated by this guy every time. I have a 10 secrets, 10 DEKs will be created, and 10 different envelope encryptions will be, means like a 10 envelopes. You wanted to write a 10 people a letter, you have to use a 10 different envelopes, right? You cannot keep it, put it in a one envelope and send it to the by post, right? The same. Now these DEKs are wrapped with the KEK. So we know this is a KMS and data encryption keys, but internally that we won't be able to see. There is a KEK, key encryption key. This will take care of creating a DEKs, right? So that's what I am telling. And KEKs are managed by, of course, this guy, the KMS, whoever is the provider, not only AWS, any other cloud you use, either one. And how? In the Kubernetes cluster level, there is a KMS plugin. That plugin is deployed as a gRPC. That gRPC will talk to remote KMS. That we'll see in the next slide. So KMS provider point of view, yes, two version. Let's say this is a Kubernetes cluster, and there is an encryption configuration you have created by using a KMS. Let's consider, and you will define a KMS plugin as a gRPC in the same Kubernetes cluster. You will install as a Unix socket, right? And that socket will communicate to this particular remote KMS. So encryption configuration to KMS plugin, which is hosted as a gRPC, and that plugin will talk to remote KMS. Whatever the envelope encryption happens in a etcd database, which happens through the remote KMS. So this will just work as a mediator. That's how the what's the KMS provider, which they are telling about, introduced KMS v2 API. Now say if I use this encryption, right? So instead of here, if I use the KMS, is done. I am using a KMS. No, that's not the case. If you use the AES CBC encryption, you will use some base 64 encoded secret. So here, right, I'm using a ESCBC and go to the my console here. Let's say echo and learn with GVR, and it require GVR, learn with GVR, something like a big string, and base 64. If I encode, this is the my base 64 encoded string, where you will copy the base 64 encoded, because this key, this is kind of a my key. My key is what? This is the my key, right? And go to the slide. But if you use the KMS, you will define an endpoint. Endpoint is nothing but it's a Unix socket. What is this Unix socket? If you go and Google about the Unix domain socket, this is a very good website. Thanks to these guys, they made it awesome with the diagram. What is this domain Unix domain socket, right? So it used to communicate on the different computer, and you can use it as a UDP and other features. So it's, so this will basically, this will communicate to the remote KMS, as simple as that. Now KMS v2, right? And if you go to the Kubernetes documentation, they mention that there is a KMS v2 introduced. But what is a v1 and v2? We know v1 means it used to, so only the difference is the API version is different, rest all are same. I know, right? So v2 is definitely the new version which has more features. What are the features? Performance, key rotation, health check status, observability. So they improved a lot with respect to key, because people may use a cloud related keys. That's what they have mentioned. And in order to use this KMS v2 in your Kubernetes cluster, you have to enable the feature gate KMS v2 equal to true. That is there in the documentation. So here it's mentioned here, feature gates equal to VMS equal to true. So since it's an alpha feature, so you have to manually enable to use this particular feature. Now go back to slide. Now next is demo. Now the demo point of view, I will use the secret encryption implementation steps. So I have a Kubernetes cluster. Yes, it's there already, Kubernetes cluster, right? And the steps point of view, the first steps, create a customer key and encode it. So I have already the customer key, which I took 15 characters. Why? Because as per the KMS provider configuration point of view, this key should be 15 digit minimum. So GVR, learn with the GVR is my key and base 64 encoded, and I will copy this particular key, right? And once it is done, then configure encryption configuration YAML file. So I have this encryption configuration YAML file, and I will just go to my console and just copy this, right? And I will go to the YAML file, and this is the, so it's a very simple encryption configuration I want to do for secrets, and this is the what the provider I am using. I am not using a KMS, right? And the key 1, I will use this key. So as many number of keys you will use, but I, for the testing purpose, I will use a 1. This is a list, by the way. It's a dash means list. So now the next is configure encryption configuration at API server. So I have my YAML file is ready. So what I will do is I will go inside the master node, right? And where is the our files are located at C, right? And Kubernetes PKI, right? This is the what the location where all the certificates are located, right? Now I will create a new folder here, mkdir KMS. There is a folder I will create. So cd KMS, right? So here I will try to paste this particular file. So I will just copy this particular file, my encryption configuration enc-config. So here enc-config.yaml, then I will paste it here, and right, so it's done. Now cat enc-config.yaml file and pwd, and this cat config /enc config.yaml. So I will copy this particular file. Now I have to go back to the Kubernetes where API server is located, because currently now I am doing this API server level configuration, right? So now clear ls, right, cd manifest, right, and ls. There is a kube API server, so vi kube API server.yaml file. This is the my kube API server static pod YAML file. I'll just go anywhere and just insert a new line, and what here we need to apply is here just go to the documentation, right? It's here clearly mentioned --, encryption provider configuration equal to that path. So I will just copy this, go here --, encryption provider configuration equal to the path. The path is etc pki and KMS /enc-config.yaml. So why I choose this particular path is this particular folder is already volume mounted here in the API server level, so I need not to remount this particular path again and again. So if you look at here, etc Kubernetes PKI is already mounted, and there is a volume also there, etc Kubernetes PKI, right? Yeah, this is the one, right? So now I will just try to save this particular file. So now I will come back here and clear kubectl get node. Definitely my kube API server will be down, so I will pause the video for a while and it will be up. Now my kube API server is up after some time. So now if I go back to the my pods, and this is the my kube API server, and kubectl describe pod my kube API server, and when I press enter and go here, encryption provider configuration equal to, this is the path where it's pointing, right? And if I go here and cd, right, and cat, this is what my encryption provider config, and this key is GVR learn with GVR, right? Now this one. Next is mount the volumes. Yes, of course it's already there. Now create the secret and test. Now point of view, I will go back to our main node, right, and this clear kubectl get secrets, right? Only one secret is there. Now kubectl create secret. Instead of secret 1, I will create a new secret which is secret 2, which pwd equal to, instead of admin 123, I will just use token equal to just something different, and admin at 321, or just like a admin @123, just something different. So I will use a token, right? So I will just create a secret. It's created already. Now, so how to verify that? In order to verify, there is 3 different ways where we have seen, right? Now first way is kubectl get pod in the kube system. Go to the etcd database and check whether how it's there, right? So the first how we verified is we went to the etcd database and we verified, right? So by using this is the particular command, right? And in the etcd database I wanted to check with secret 1 which is not encrypted, admin 123, but I will fire the same query, but instead of that secret 1 I'll just simply use secret 2, right? And when I press enter, my secret 2 is encrypted and human cannot read. And the one good thing is here K8s ENC, which is encryption, AES-EBC, which is, if you carefully observe the encryption configuration, AES-EBC I have used the provider, and v1 which is my API version v1, and key 1 which is a key, and you can use the multiple keys as well as you wish, as how you wanted to implement the encryption, right? So this is the one way. And another way of checking is go to the master node and SSH into the master node, and where is etcd specific, where is there cd f1 var lib and etcd, and go here ls, so cd member ls cd snap ls, yeah, there is a db file vi db. So when I go here, secret 1 my admin 123 is clear text, but when I go and enter secret 2, which is encrypted by default, you see K8s Kubernetes ENC is nothing but encryption, EACBC, and v1 is my API version, and key 1. So all these as per my this encryption configuration. So that's what it mean. And there is a third way as well, and which I will show. Third way is, first you need to have a etcdctl should be installed in the local machine in your master node. Yes, in my master node it was installed, and then you need to write this particular query, etcdctl, right? So this is a command which I have noted here, right? So instead of secret 1, this is the secret 1 specific data, and secret 2 specific. So you need to pass etcdctl equal to 3 etcdctl cassert, what we have learned in the CKA, and secret 2, when you do the hexadump, and in this particular hexadump you will be able to find out a secret 2 which is purely encrypted, but whereas the secret 1 is not encrypted. So that's all. And if you wanted to encrypt all the secrets, so if you go here, right, kubectl get secrets, right? So here only secret 2 is encrypted, but only secret 1 is not encrypted. And also secret -a, if you do that, these are the 4 secrets. You wanted to encrypt all the secrets. How to do that? So there is in the documentation, you scroll down, encrypting a secret data at rest, right? Ensure all secrets are encrypted. Just you copy all namespaces you wanted to replace, recreating. That's what they're doing. Just simply do this. Yes, total how many? These 4 secrets are encrypted already, right? And but if you look at the pod level, right, and check here, secret 1, yes, now it's encrypted. This is proved that after applying encryption configuration, everything is encrypted. Yeah, so that's it for this particular session point of view. I hope this session is helpful, and please let me know your feedback in the form of a comment, and also please subscribe, like, comment, share, and everything. Thank you for listening. Bye bye.